AI ethics and bias are something marketers really have to think a lot about. AI can affect brand trust and reputation because biased AI systems can perpetuate stereotypes or unfairly exclude demographic groups. This can alienate people. Trust can be eroded if consumers perceive marketing content as discriminatory or manipulative. There's consumer backlash if AI-driven campaign decisions are perceived as deceitful, it's exploitative, or insensitive. So we really need to guard against some of those AI ethics and bias issues that can show up. Bias can also skew segmentation, causing you to miss valuable or underserved segments. Personalized content can become exclusionary or reinforce harmful stereotypes. Flawed predictive models can lead marketers to allocate resources inefficiently. So there's lots of different things, and even some legal and regulatory risk, like transparency and fairness, and automated decision making. Biased AI can expose brands to legal fines or compliance penalties. Um, Regulators are increasingly scrutinizing AI-driven marketing, so brands need to be proactive in auditing their systems and maintaining ethical standards. So, what are some common issues that we see with large language models? Things like hallucinations, bias, and stereotypes, and even sensitivity to input phrasing can be issues. Understanding these issues is the first step in learning how to effectively mitigate those. So hallucinations, AI hallucinations occur when a large language model generates incorrect or nonsensical information that seems to be plausible or factual. These hallucinations are not due to malfunctions, but rather to how LLMs are built. LLMs are designed to predict the next word based on patterns they've observed in the data that they're trained on. Sometimes those predictions end up being wrong. So here's some hallucination examples. You might have heard of the story of a lawyer using ChatGPT to cite judicial opinions on a client's case. The only issue was that those were opinions made up by ChatGPT. A 2023 study on the authenticity and accuracy of references generated by ChatGPT for medical journals found that 47% of references were fabricated, while another 46% were authentic. Excuse me, were authentic but inaccurate. The third chart shows a hallucination leaderboard created by Victoria, and you see that models are getting better over time, with ChatGPT models having hallucination rates below 2%. These LLMs are getting better, but you can't expect 100% accuracy when working for them. You need to think about the types of requests and subject matters that you're working with, and how that might result in higher inaccuracies or hallucinations. We also need to worry about bias and stereotypes in large language model output. Bias occurs when a language model generates outputs that reflect prejudice or unfair preferences based on race, gender, ethnicity, religion, or other characteristics. Stereotypes are just oversimplified generalizations about a group that may appear in the model's responses. These biases and stereotypes are often a reflection of the data that the model was trained on, which often includes biased information. Here we see the beginning of some issues with bias and stereotypes inside of ChatGPT. When I asked the large language model to create an image of a doctor or a scientist, they provided an image of a Caucasian male. Now, this wouldn't be a big problem if it did this for every single job, but let's look at some other job titles. Here we see pictures created by AI for a housekeeper and nurse. And neither the last slide or this slide did I ask for a specific gender. ChatGPT assumed the gender of the roles because of the data it was trained on. Based on that, it assumes that scientists or doctors are likely to be male, while housekeepers and nurses are likely to be female. We have to be aware of this bias and stereotyping when we ask large language models for output. So you might be wondering, what are the causes of bias and stereotyping? Some of those causes are the training data. Large language models are trained on large data sets that can contain biased or unrepresentative information. There could also be some issues with historical or social biases. Existing societal biases are often embedded in text data that large language models are trained on. You could also blame this on a lack of diversity in data sources. Overrepresentation of certain viewpoints or groups can lead to biased outputs. The consequences of this are potentially the perpetuation of stereotypes, discrimination, and loss of trust. Users may lose trust in AI systems and the companies that use them if they're consistently producing biased outputs. So, you need to think about how to mitigate problems with large language models. One of the first ways you can mitigate a problem is by careful prompt design. The clearer and more specific your prompts, the less likely the model is to produce biased or incorrect information. You also need to think about fact generating your output and continuously monitoring and evaluating what you're producing. Fact-checking large language models can be tricky, but there are some things we can start with. First off, there's inbuilt large language model capabilities. Some models, especially newer ones, have built-in fact-checking features. You can ask the model to provide sources or citations for specific claims, or some models can be prompted to generate responses with higher factual accuracy. The most straightforward way is to copy potentially questionable statements from a large language model and paste them into a search engine like Google or DuckDuckGo, allowing you to cross-check the information with reliable sources. You can also use dedicated fact-checking websites to see if the model is producing accurate information. And one final thing you can do is ask large language models to provide explanations for why a claim might be true or false to reduce over-reliance on incorrect information. Having to fact check large language models can really defeat the time savings you get from using the large language model in the first place. So, what information should you spend time verifying? You need to consider a couple of things. One is how important is the information? If it's high stakes information, and you're going to be using a model for important decisions, you need to verify all claims, even if those that seem obvious. If you're just using it for casual information, for general knowledge or entertainment, you can be a little bit less rigorous, focusing on verifying only the most surprising or controversial claims. You need to also consider the source of the information. If the large language model cites sources you're unfamiliar with, be sure to check those sources' credibility and verify the information independently. If it's using established sources, it's generally more reliable, but it's still good practice to double check critical information. You also need to think about the types of information. Facts and statistics are easier to verify. Opinions and interpretations are subjective and harder to verify, but you can look for supporting evidence or alternative viewpoints. Predictions and speculations are inherently uncertain, so focus on verifying underlying assumptions rather than the actual prediction itself. You also need to consider the context of the content. Check to see if the information is still up to date, especially for rapidly changing fields. Consider your own knowledge and expertise as well. If you have expertise in a particular field, you can use your knowledge to assess the plausibility of the model's output. Even without specific expertise, your general knowledge can help you spot inconsistencies or inaccuracies. Remember, when you're dealing with LLMs and its output, be skeptical. Don't take everything for granted. Even if the model seems confident, always question and investigate the responses further. Use multiple sources. Cross-check your information with reliable sources to ensure its accuracy, and focus your verification on the most critical or uncertain information.